Welcome to Ramreddy Pharma YouTube channel. In the last video, we have discussed about the principle and basic instrumentation of the mass spectrometry. In the basic instrumentation, we are having few important parameters or few important topics are there, that is ionization technique and mass analyzers. In that today, we are going to discuss about the ionization techniques or ionization methods. So basically, the main aim of this ionization method or technique to convert the gaseous molecule to molecular ions. So for ionization of the molecule will be happening that this ionization source. So here we are having different methods or techniques are available for ionization. The first method is electron impact ionization, chemical ionization, field desorption, fast atom bombardment, electrospray ionization, plasma desorption, matrix assisted laser desorption ionization. It is called as MALDI. So electron impact. The electron impact is nothing but impact or bombardment of the high energy electrons with the molecule is called as electron impact. So in this directly the high energy electrons from the rhenium wire is directly impact with your molecule. So the free electrons which are emitted by the rhenium wire in contact with the your molecule. That time the molecule will be converted into molecular ion by removal of one electron from the your molecule by the high energy electron. So after that the molecule will be converted to molecular ion. So whatever the molecular ion formed, sometimes it will be unstable and it will be further fragmented by the high energy electrons into the small fragments or radical and cation. So this process is called as fragmentation. So here once you see here, this is your molecule. So this is your high energy electron from the rhenium wire. So when these high energy electrons are impact with your molecule, that time one electron will be removed from the molecule and it will be causes the ionization of the molecule. So that time the radical cation is formed. It is called as molecular ion. So as this radical cation is unstable, again the high energy electrons are impact with your molecular ion. That time it will be further fragmented into small fragments. So now the molecular ion is fragmented into two fragments, M1 plus and M2 radical. So this is called as fragmentation. So why we are calling it as hard ionization technique means it is directly hardly it will be hitting your molecule. So that's why we are calling hard ionization technique. Because of this directly hitting, the molecular ion will be further divided into fragments. Next is chemical ionization technique. The chemical ionization technique is also called as soft ionization technique. So why we are called this soft ionization technique means, so it is different from the electron impact. So in this, the ionization is indirectly happening. The ionization is happening indirectly means in electron impact, directly the high energy electrons are impact with the molecule. But in this chemical ionization, it is not like that. In this, we are using one reagent gas. One reagent gas we are using. So the commonly used reagent gases are methane, butane, and ammonia. So first we are along with the gaseous molecules, we are also introduce this reagent gas. And when high energy electrons are enter into the ionization source, first these high energy electrons, first the high energy electrons are collide or interact with this reagent gas. Means initially first the reagent gas will be undergo ionization and then it will be produce the some electrons. So first what happened, the reagent gas is pumped directly into the ionization chamber and electrons from the uranium filament ionize the reagent gas. First, the reagent gases undergo ionization. Once you see the reagent gas methane, the high energy electron from the filament will be interact with each other. That time, the reagent gas will be undergo ionization. So now the ionized reagent gas. Now this is your ionized reagent gas. Then it will be interact with your molecule. So that time the molecular ion will be formed. Means here indirectly the high energy electrons are causing the ionization of the molecule. Means they are not directly hitting the molecule. So but in case of chemical impact, the molecule So directly, the high energy electrons are directly impacting your molecule. That time there is a chance of breakdown of your molecule will be happen. But in this case, first the high energy electrons are impact with the reagent gas. Now the reagent gas will be undergo ionization and there is a chance of fragmentation of reagent gas. Here once you see, the fragmentation of reagent gas will be happen. Now the ionized reagent gases interact with the molecule and causes the ionization of your molecule. So that's why we are calling it soft ionization technique. And the next one is matrix assisted laser desorption ionization or MALDI. Especially in this technique mainly used for thermoliable and non-volatile organic compounds. This method mainly used for thermoliable non-volatile components like proteins and peptides and glycoproteins. This is also one type of soft ionization technique. So means the fragmentation will be very less in the soft ionization techniques compared to the hard ionization technique. In hard ionization technique, the high energy beam of electrons or high energy molecules are directly hitting with your molecule. In soft ionization technique, they are not directly hitting the molecule. The high energy electrons are not directly hitting your molecule. In between, one thing is present. First, that will be undergo ionization. So once you see here, in this matrix assisted laser desorption, we are using a one matrix. We are using one matrix. In this matrix, we are keeping our molecule. So what happened? So an laser desorption technique means we are using the one laser light to causes the ionization. So in the MALD is based on bombardment of sample molecule with the laser light. So we are using laser light to cause the ionization of the our molecule. So that's why we are calling as matrix assisted laser desorption. In this what happened? Our sample is pre-mixed with the absorbing matrix compound. Means first one matrix compound will be there. So in the initially we are mixing our compound or our molecule with the pre-matrix. So that time what happened? Around our compound, the matrix is coated. The most commonly used matrix components are cyanopic acid is the most commonly used matrix material for the common protein analysis. So once you see here, so this is the green color ones are the matrix material, nothing but one polymeric type of material. And to this we are mixing with the our compound or analyte. So somewhat a red color, yellow color is called as our analyte molecule. So now what happened? Initially the laser light the laser beam is exposed to the premixed sample containing matrix. So now initially what happened? The laser light produces some energy. Now that energy will be absorbed by the matrix. First what happened? It will be absorbed by the matrix and then the matrix transform the laser energy into excitation energy for the sample. So first the required amount of energy only is transferred from matrix to your sample for excitation, for conversion of molecule to molecular ion. So first what happened? The matrix transfer the laser energy into excitation energy for the sample, which leads to sputtering of analyte and matrix ions. First the matrix undergo ionization. So that time it will be having some energy. These energy, whatever the energy generated from the matrix ions are transferred to your analyte molecule. So the excess laser energy is stopped at your matrix only. Only required amount of energy, laser energy is transferred from your matrix to molecule. So in such a way, the molecules are converted to molecular ions and we are avoiding the decomposition or fragmentation of your molecule. So that's why this technique is called as soft ionization technique. So these are all the different types of compounds, matrix compounds, and what type of solvent we are using for what is the application, for which compounds, which type of polymeric or matrix materials are we are using for the ionization. Next is fast atom bombardment. The fast atom bombardment, here what happened means one metal target will be there. This is your metal target. So in this metal target, what happened means one matrix material will be there. This is a matrix material will be there. So in the matrix material, our compound will be there. We are keeping our compound. Generally, fab utilize the a fast moving atoms. So this a gun will be there. Say a fast moving a gun will be there. From this gun, a beam of neutral atoms are strike the are bombarded with the your metal target. To this metal target, we are coated with the liquid matrix in which our sample is present. Means this is your a fast atom bombardment gun. A atom gun will be there. From this one, a atoms are coming or interacting with the your metal target. From this, what happened? The neutral atoms like xenon or argon will be they are coming outside of this gun with the very speed, and it will be interact or bombarded with your metal target. So once the metal target will be uh, the atoms are strike the metal target, that time what happened, the energy of these atoms will be transferred to the your matrix which containing compound. So automatically what happened, the sample will be undergo ionization, the sample ions will be formed. Now then that sample ionization will be completed, then it will be released to the your mass analyzer. This is the fast atom bombardment. And plasma desorption. The plasma desorption, it is also called as fission fragmentation technique. In this, we are using some nuclear fission technique. Means we are using some isotopes. So the isotope most commonly we are using as Californium isotope. So in this technique, the ionization technique in which ionization of the material will be a solid sample. First, we will take the solid sample take place by bombarding with the ionic or neutral atoms produced by the fusion of your radioactive material. So when the radioactive material will be undergo fusion, that time some neutral or ionic atoms will be produced. That neutral or ionic atoms will come and directly bombard with your sample. That time the sample will be undergo ionization. So this is called as plasma desorption ionization technique. And next is electrospray ionization technique. In electrospray ionization technique, especially used in the technique where the liquid chromatography is combined with the mass spectrometry, means LCMS. So this is also one type of soft ionization technique. So when it is called as soft ionization technique, the fragmentation is very, very little. So how this electrospray ionization will be works once you see here. In the electrospray ionization, so we are having one nebulizer or spraying nozzle. So through this spraying nozzle, your sample, your liquid sample will be sprayed as a small droplets. So here to this nozzle, to this spraying nozzle, we are applying the power supply electric field. So that time what happened, the liquid droplets will be formed. So to the liquid droplets, what happened, a charge will be present. So this is the charge will be present. So in the form of, we are calling charged parent droplets. So what happened, now this is the droplet. In the droplet, your analyte molecule will be there. Around the droplet, the charge will be generated. When here the liquid sample which containing our analyte solvent and analyte will be there. They are sprayed from the spraying gun or nozzle in the form of a small droplets, and to this spraying gun we are applying the electric field. So when we apply the electric field, the droplets have having some charge. Now what happened, to this we are giving the heaters. We are also apply the heaters. Upon heaters, what happened, these droplets containing the solvent is evaporated. Once the solvent will be evaporated, a cooling fission will be happen, and that time a charged droplet will be formed. So first, this is the droplet, the charged droplet. So a cooling fission will be happen. So that time what happened? The droplets will be undergo fission. That time each analyte will be with the some solvent form as a small droplet. From now what happened? As due to the heating, heaters, the solvent will be evaporated and the naked charged particles will be formed. So this is the how the electrospray ionization means spraying the sample in the form of a fine droplets by applying the electricity. So that time what happened? The compound or the analyte will be undergo ionization. That's why we are calling electrospray ionization. So this is the another diagram how it will be there. So we are applying the high voltage power supply, and here the liquid sample will be coming as a small droplets. So in the form of a some cone like structure, that's why we are calling it as Taylor cone. So from this droplets, again they are undergo some small fusion droplets. So initially one droplet will be there. In this droplet so many analyte molecules are there. When undergo fusion, each droplet with one analyte will be present. Then what happened? The solvent is evaporated. When the solvent will be evaporated, the analyte will be having the naked analyte with the charge will be uh, produced. So this is the how the molecules will be converted into molecular ion by using electrospray ionization technique. So these are the different types of spray ionization techniques commonly we are using the mass spectrometry. Apart from that, we are having different ionization techniques like APPI, atmosphere pressure photoionization, atmosphere pressure chemical ionization. These two are mainly used for the LCMS or LCMS. These are the isonated techniques. So these are the different type of ionization techniques commonly we are using. Chemical ionization, electron impact, ESI, electrospray ionization, MALDI, fast atom bombardment, and plasma desorption. Thank you. Thank you for watching this video. And for more updates, please subscribe our channel.